Okay, so we're here today with Dayan from TT Suspension, distributor of TracTive active suspension systems over here in Australia, and he's going to be talking to us today a bit about the active suspension system on the RP968 Porsche. So, Dayan, thanks for coming on board, and would you like to just sort of run us through why you've gone for an active damping setup on this car?
So the benefits of active damping, particularly in time attack cars, based on the fact that these cars run significantly stiffer than most track cars. They're often, due to the aero loads, heavily compressed into bump rubbers, and so we're experiencing different spring rates based on their ride heights. Alongside that, we can also vary our damping as a function of the speed and the position on the track, and so we can vary our damping to favour traction, cornering grip, aero grip, etc.
So when we talk about active, what are we actually controlling? Is it just the damping, or is it bypass position zones or something like that?
Yep, so technically these are semi-active. They're what you call a low bandwidth. They take in less energy. They only run between 0 and 2 amps. And what they do is they're a variable damping setup. So they change the damping rate as a function of the current that goes through them. They're not used to elevate or lower the car like they used to do in Formula One days. These just vary their damping as a function of the inputs.
So could you just give us a quick run through of how the mechanism in this damper actually works?
Okay, so they work in principle like a normal gas damper. They have an oil inside, a piston, shim stack, etc. What they have that's different is they have a magnetic solenoid in part of the assembly, and inside the solenoid moves and opens and closes a valve which controls the oil flow through the piston and through the rod, and therefore we can open and close it. So if you were to have, for example, a one-way adjustable damper, you would be doing the manual version of that, but these are electronically controlled.
And what sort of things can we control? We've got high speed, low speed, rebound.
Yep, you can control the damping high speed. You can control the damping at low speed. You can control it as a matter of any inputs as you can. So you can reshape the curve on the fly. These have a response time of 6 milliseconds from full hard to full soft. So you can change the damping as fast as you can log and control the car.
And on the RP968, are you mapping this to track position or driver input or ride height, or what control that?
So our inputs on the RP968 are ride height, so damper potentiometers, lateral Gs, longitudinal Gs, roll rate, pitch rate, and then we have 5 user settings, 5 modes that we can operate. And so we can use the Motec dash to switch those modes as a function of any other variables, which might be lap distance, speed, position on the track, etc.
And is there scope to implement some sort of active ride height control to allow compensation for aerodynamic loads and trying to keep a ride height level?
TracTive Suspension also offer what they call an EPA, electronic preload adjuster, and what it is a hydraulic cylinder that sits under the spring. It can travel about 15 millimeters in 15 seconds with a 10 kilonewton load, so it can be used to control ride height in time attack cars. They're often used on motocross bikes, and they're used on road cars that to help a low-lying road track car to then be able to run on the road and go over speed humps.
And could you employ this sort of technology in, say, something with more significant bumps, like, say, an off-road race car?
Yeah, so we are currently looking at using these dampers in gravel rallying. We're successfully using them in tarmac rallying, and I've had a lot of success at Target Tasmania this year with a few clients. In off-road, you could use these over longer travel, although that hasn't been an area that's been developed. However, the area of motocross is a huge area that TracTive Suspension is very successful in, so large travel and lots of high forces.
And what sort of money would you be looking at for a setup like this?
So the price depends on whether the products are existing in the catalogue. The benefit of TracTive Suspension, especially with their partners in the USA, DSC Sport, there are already kits for plug-and-play kits for Nissan GTR, Porsches, etc. And so a kit with a a plug-and-play set is normally around $7,000 to $8,000 US. A similar kit that you would get then with canisters and a controller might come up to the $10,000 US mark. And we find that a full kit that you would put in a tarmac rally car, which will include a controller and dampers, might be around about $12,000 or $13,000 US, which is not a significant price difference considering the huge gains in technology and road and chassis holding.
So now that this tech has been running on the RP968 for this weekend, what sort of advantages have you found, and what sort of adjustments have you made to both the dynamic and the static mapping of these dampers?
So the biggest advantage we found this year with these dampers is that we're able to run 2 hot laps on a set of green tyres. None of our competitors are able to do that, so it gives us the opportunity to learn on 1 lap, get the driver up to speed, adrenaline rushing, and then have another go. And also we get to make a damper change. The driver can make it himself through a mode adjustment while he's out there. We're making gains in track time, we're making gains in knowledge, and so these are all equating to progress along the way. The kind of changes we have been making to the mapping, we've really been working on roll control of the car, particularly the inside wheel stiffness. We now find that we're very comfortable using curbs, unlike other time attack cars. Our inside wheel is quite flexible over bumps, so you can maul the curbs, jump all over them, but we still have good roll control. And that's where we're making a lot of aero gains because we're keeping the car flat.
And is there any more scope in terms of doing this as an active spring rate as well for each wheel spring?
I don't know about active spring rate. Currently we can say we're quite progressive because we have quite a stiff spring feeding into a stack of bump rubbers. But the fact that the damper resistance can also be made as a function of suspension position, you can say that we are effectively changing our spring rate because our force versus deflection varies.
Okay, great. Well, thanks heaps for talking to us today, Dan. It's been really fascinating listening about this suspension technology.
Great.
And thank you for coming along.
Thank you. Thanks for having me.